Questions 1 through 10 on the 2009 Grade 12 AMC 12B. Each morning of her 5-day work week, Jane bought either a 50-cent muffin or a 75-cent bagel. Her total cost for the week was a whole number of dollars. How many bagels did she buy? 0.5 M for muffin plus 0.75 B for bagel is the total cost, and that has to be some integer. So let's go through the scenarios. Each day she buys either a muffin or a bagel. So we can't have 0 for either M or B. So let's start with 1 for B. And if B is 1, then M must be 4, right? Because she has to buy one or the other for the total work week. So that means this would be 4 times 0.5, which is 2, plus 1 times 0.75, which is 0.75, and that is equal to 2.75, which is not an integer. So this is wrong. Let's go to 2 bagels and 3 muffins. That would mean 1.5 for that cost, and then 2 times 75 cents is 1.5, and that equals 3, which is indeed an integer. So that means B must equal 2. So number 1, the answer is B. Paula the painter had just enough paint for 30 identically sized rooms. Unfortunately, on the way to work, 3 cans of paint fell off her truck, so she had only enough paint for 25 rooms. How many cans of paint did she use for the 25 rooms? So since X will represent the total cans of paint, X minus 3, because 3 cans fell off, is how many she needed to paint 25 rooms. And then X was how many she needed to paint the 30 rooms. And this ratio is equal. So we just have to multiply, cross multiply. So 30x minus 90 is equal to 25x. And therefore 5x is equal to 90. So x is equal to 18. Now we don't want x, we want x minus 3, because that is how many cans of paint is required for her to paint 25 rooms. So x minus 3 would be 18 minus 3, which is, of course, 15. So number 2, the answer is C. 20% less than 60 is 1/3 more than what number? So 20% less than 60, so 0.8 times 60 is 1/3 more. So 1 plus 1/3 is how we are going to do that. So 1 plus 1/3, and we'll call the number x. So this is the mathematical formula we have to figure out. So this left side becomes 48, the right side becomes 4 over 3, and then if we cross multiply, we get 48 times 3 over 4 is equal to x, and therefore x will be 36. So number 3, the answer is D. A rectangular yard contains 2 flower beds in the shape of congruent isosceles right triangles. The remainder of the yard has a trapezoidal shape as shown. The parallel sides of the trapezoids have lengths 15 and 25 meters. What fraction of the yard is occupied by the flower beds? So this is 15, this distance right here, and this bottom distance is 25. So that means that these guys are 5 and 5. And since this is a isosceles triangle, this is also 5, as is that side. So they want the fraction of the yard that's occupied by the flower beds, and the flower beds are the ones that are shaded. So there's 2 of those, and each of those has an area of 1/2 base times height, which is 5 times 5. And the total area of the entire yard is 5 times 25. So there you go, that's the fraction. So the 2 times 1/2, that cancels, becomes just 1, and then this 5 cancels with that, so we're just left with 5 over 25, and that is 1 over 5. So number 4, the answer is C. Kiana has 2 older twin brothers. The product of their 3 ages is 128. What is the sum of their 3 ages? Kiana, and then we'll just call them brother and brother. And if you multiply those three ages, it's 128. And what we need to find is K plus B plus B. Now, 128 is 2 to the power of 7. So K times B has to be 2 to the power of 7. And the only way to arrange that is to have 2 to the power of 1 times 2 to the power of 3 times 2 to the power of 3. There's no other arrangement that works, because keep in mind two things. The first is that they're older brothers, so B has to be greater than K, and then they're twins, so that's why they're equal in age. Alright, so this is the only scenario, so that basically means that K is equal to 2, and the two B's are equal to 2 to the power of 3, which is 8. So K plus B is 2 plus 8 plus 8, which is 18. So number 5, the answer is D. By inserting parentheses, it is possible to give the expression 2 times 3 plus 4 times 5 several values. How many different values can be obtained? Okay, so we got to fiddle around with this. So let me write out a few and let's see what we can do. Well, I can put brackets here, I can put brackets here and here, and then I can put brackets around those guys and these guys. And I think that is it. The only other ways of doing it would not result in anything different, I think. So let's figure out what these values are. Well, this one doesn't really do anything. It just still is 6 plus 20, which is 26. The next one, okay, this one I think changes things. It becomes 2 times 7 times 5, which is 14 times 5, which is 70. This one doesn't do anything. It's the exact same as if you didn't put any parentheses. This one definitely changes. 2 times 3 is 6, 6 plus 4 is 10, so 10 times 5, 50. And the last one, let's see here, 4 times 5 is 20, 23, so 23 times 2 is 46. And I think that's it. So the number of unique values or different values we got was 1, 2, 3, and 4. So number 6, the answer is C. In a certain year, the price of gasoline rose by 20% during January, fell by 20% during February, rose by 25% during March, and fell by X% during April. The price of gasoline at the end of April was the same as it had been at the beginning of January to the nearest integer, what is X. Let's just say we start with 100. It's always easy to work with a number. $100 per liter. Whatever, right? It doesn't really matter. So at the end of January, we are rising by 20%. So 1.2 times 100, and that is, of course, 120. And then at the end of February, by that point, it had fallen by 20%. So 0.8 times this 120 is our new price, and that is 96. And then at the end of March, it rose by 25, so it's 1.25 times this 96, and that is 120. And then at the end of April, let's see here, that's when the X, okay, fell by X%, so it would be 1 minus X over 100 times this 120. And they're saying it is equal at that point to what it was at the very beginning, which I had denoted as 100. So here's the equation that we have to solve. Okay, so 1 minus X over 100 will be 100 over 120. And then if I put everything on one side, it becomes X over 100 is equal to 1 minus 100 over 20. 120 is 10 over 12, which is 5 over 6, right? I think. So X over 100 will be 1 minus 5 over 6 is 1 over 6. And therefore, X looks like it is just going to be 100 over 6. And 100 over 6 is approximately 16.67, right? And they're saying to the nearest integer, so to the nearest integer, x would be 17. And that would be choice B for number 7. When a bucket is 2/3 full of water and the bucket and the water weigh A kilograms, when the bucket is 1/2 full of water, the total weight is B kilograms. In terms of A and B, what is the total weight in kilograms when the bucket is full of water? So we have some bucket and it has two scenarios. One is 2/3 full and the other is half full. Now the total volume I will call W. So that's my total volume of water. Now they are telling me the first scenario is that 2/3 of the water plus the bucket, I'll call that B, is equal to A. And then the second scenario is when you have half of the water plus the bucket, and that is equal to small b. So these are my two equations, and they want me to find the value of W plus B, but in terms of small a and small b, because all the answer choices are small a and small b. Okay, so let's proceed with this. Let's see here. Well, I guess the first thing we can do with those two equations is just subtract them. So we got 2/3 W minus W over 2, and the b's, it'll be B minus B, so that will cancel. And then on the right side, you're just going to have A minus B like this. Okay, so 2/3 minus 1/2, so that's going to give me 1 over 6. So this is just going to be W over 6 is A minus B. So W is 6 times A minus B. And then at this point, we can just substitute this into either one of these, and that should be sufficient, I think. So I'll substitute it into this guy. So that means I've got W over 2, but W is 6 times A minus B, all over 2, plus B is equal to B. So that means the big B is B minus 3A minus small b, like that. So I've got W and big B. Now I can figure out W plus B. So W plus big B, which is what they want us to figure out, is 6A minus B plus B minus 3A minus B, and that is 6A minus 6B plus B minus 3A plus 3B. Collecting like terms, let's see here, 6A, 3A, and then minus 6 plus 4 minus 2B. And that is choice E for number 8. Triangle ABC has vertices 3, 0, 0, 3, and C, where C is on the line x plus y is equal to 7. What is the area of ABC? Let's draw a little graph and let's see what we can figure out. So I have A is 3, 0, so probably let's say about here. This is A, 3, 0, and B is 0, 3, so approximately here. That is B, 0, 3. And then we have this line x plus y is 7, and we can quickly figure out the x and y intercepts by plugging in 0 for each. When x is 0, y will obviously be 7, so about here. And when y is 0, x will be 7, so approximately here. So this is our graph. And then they're saying that C is somewhere on this line. C is on the line. So why make things complicated? Let's just put C right here. It's on the line. If it's on the line, it qualifies. So there we go. That is my triangle. So I can now connect C to A to B. So there we go. C to B to A. And then, of course, C has to be connected to A. Now I have to figure out the area of that. And the area, therefore, is 1/2 base times height. The base is from here to here, which is going to be 7 minus 3, which is 4. And the height is going to be from there to there, which is obviously 3. So I've got 12 divided by 2, which is 6. So number 9, the answer is A. A particular 12-hour digital clock displays the hour and minute of a day. Unfortunately, when it is supposed to display a 1, it mistakenly displays a 9. For example, when it is 1:16 p.m., the clock incorrectly shows 9:96 p.m. What fraction of the day will the clock show the correct time? So this clock apparently shows numbers anywhere from 1:00 to 12:59. Right? That is our scenario. So we'll make a little table and we'll talk about incorrect times and we'll talk about correct times. So first, let's talk about when the clock is 1 something, 1 o'clock, 1:20, 1:30, like that. Because there's a 1 there, every single time from 1 to 1:59 will be incorrect because it's always going to show the 9. So all 60 minutes will be incorrect. So there's 60 out of 60 will be incorrect and 0 will be correct. Now when we get to the times that involve 2 something, a lot of those will be correct, but the ones that will be incorrect are 2:01, anything from 2:10 to 2:19, because those all have 1s, 2:21, 2:31, 2:41, and 2:51. All of those will be incorrect because they have a 1 in them. They will show a 9. So we have to count how many of these there are. So 1, 2, 3, 4, 5. There's 5 plus 10, 15 of these, 15 minutes. So of the 60 minutes, 15 will be incorrect, and that means the remaining 45 will be correct. And a very similar story is true for 3, 4, 5, 6, 7, 8, 9. All of these will have the same in terms of how many correct and incorrect. And then, of course, we get to the 10, the 11, and the 12, right? All those times, 10 something, 11 something, 12 something. And because 10, 11, and 12 all have a 1 in them, any time that is shown is going to be incorrect, right? They're always going to have some 9 in there that they're not supposed to have. So 0, 0, and 0. So there we go. So we want to figure out how many are correct. So that is, in terms of a calculation, 45 times, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. 45 times 8. And then the total is 60 times 12, right? Because you have 12 hours and each hour has 60 minutes. So this is the fraction that we need to figure out. And this, we can reduce this to lowest terms. 45 over 60 is 3 over 4. 8 over 12 is 2 over 3. And this looks like 2 over 4, which is just a half. So number 10, the answer is 8.